Our lesson for today is all about proving triangle congruence. In the previous lesson, you have learned that the two triangles are congruent if and only if there is a pairing of vertices such that corresponding sides are congruent and corresponding angles are congruent. Also, with the help of the different postulates and theorem, namely side angle side or the SAS postulate, the angle side angle or the ASA postulate, the side side and side or the SSS postulate, and the angle angle side or the AAS theorem. In this lesson, you will learn to use those postulates and theorem in proving that the two triangles are congruent. We are going to use the direct proof or the two-column proof. Before we proceed with the proving, let us have the following geometric properties that can help you in proving. We have what we call the table of geometric properties. For the first column, we have the if-then form, while in the second column, we have the geometric properties. For number 1, if A is the midpoint of line segment BC, then AB is equal to BC. The geometric properties here is definition of midpoint. For number 2, if line segment AB bisects line segment CD at E, then line segment CE is congruent to line segment DE, and that is the definition of segment bisector. For number 3, if line AD bisects angle CAB, then angle CAD is congruent to angle BAD. That is the definition of angle bisector. For number 4, if angle A is a right angle, then the degree measure of angle A is equal to 90 degrees. The geometric properties here is the definition of right angle. For number 5, if angle CAB is a right angle, then line segment CA is perpendicular to line segment BA. That is the definition of right angle also. For number 6, if angle A and angle B are right angles, then angle A is congruent to angle B. The geometric properties here is all right angles are congruent. For number 7, if line segment AB is perpendicular to line segment AC, then angle BAC is a right angle. This is based on the definition of perpendicular segments. For number 8, if line segment AB is congruent to line segment CD, then AB is equal to CD, and that is the definition of congruent segments. Next, for number 9, if angle A is congruent to angle B, then the degree measure of angle A is equal to the degree measure of angle B. That is the definition of congruent angles. For number 10, if line segment AB is a segment, then line segment AB is congruent to line segment AB. And if angle A is an angle, then angle A is congruent to angle A. That is the reflexive property of congruency or RPC. Next, for number 11, if line segment AB is congruent to line segment CD, then line segment CD is congruent to line segment AB. If angle A is congruent to angle B, then angle B is congruent to angle A. The geometric properties here is symmetric property of congruency or the SYMPC. Next, for number 12, If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then line segment AB is congruent to line segment EF. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. And that is the transitive property of congruency, or the TPC. Next, for number 13, if AB plus CD is equal to AD and AB is equal to EF, then EF plus CD is equal to AD. If the degree measure of angle 1 plus the degree measure of angle 2 is equal to the degree measure of angle A, and the degree measure of angle 1 is equal to the degree measure of angle 3, then the degree measure of angle 3 plus the degree measure of angle 2 is equal to the degree measure of angle A. The geometric properties here is substitution. And for our last, if angle 1 and angle 2 are vertical angles, then angle 1 is congruent to angle 2, and that is the vertical angle theorem, or the VAT. These are some geometric properties that are very useful as you go along your journey improving triangle congruence. So, if you can memorize it, please do so, or just know it by heart. Now, let us now prove congruency of two triangles on the following examples. For our example number 1, so let's fill in the missing statements and reasons. The given, we have line segment AE is congruent to line segment CD. And another given is line segment AC and line segment DE bisect each other. So let's prove the triangle ABE is congruent to triangle CBD, given the illustration on the slides, or the slide. For our proof, for the first column we have the statements, while the second column are all the reasons. For number 1, we have line segment AE is congruent to line segment CD. The reason here is this is a given. Always start with one of the given statements, and this will be the first pair of congruent sides. Okay, next for number 2, line segment AC and line segment DE bisect each other. So the reason here is also given. For number 3, line segment AB is congruent to line segment CB. What will be the reason here? The reason here is definition of segment by sector. And for number 4, what will be the statement if the reason is the definition again of segment by sector? The answer here is line segment EB is congruent to line segment DB. Next, for number 5, triangle ABE is congruent to triangle CBD. So what will be the reason in number 5? The answer is Sss Congruence Postulate. So now let's explain the following statement. So for statement number 1, always start with one of the given statements, and this will be the first pair of our congruent sides. And that is our line segment AE is congruent to line segment CD. While for our statement 2, the reason for statement 2 is given. since it is written in the given statement. And that is line segment AC and line segment DE bisects each other. And for statement number 3, the reason is the definition of segment bisector. Since line segment DE bisects line segment AC, we can say that line segment AB is congruent to line segment CB based on our mark by the definition or segment bisector. And that is the second pair of our congruent side, which is line segment AB is congruent to line segment CB. And for our statement number 4, the answer is line segment EB is congruent to line segment DB. Since line segment AC also bisects line segment DE, by the definition of segment bisector, we can say that line segment EB is congruent to line segment DB. There is a mark on our illustration. This is the third pair now of our congruent side. And now, for our number 5, the answer is Sss Congruence Postulate because there are 3 pairs of congruent sides. I hope you understand our first example. Next, for our example number 2, let's fill in the missing statements and reasons again. So our given is line segment CJ is congruent to line segment DJ. Another given, J is the midpoint of line segment SM. Let's prove triangle CJS is congruent to triangle DJM. Now, for our first statement, the reason here is given. Based on our statement 1, the answer is given since the first statement is always one of the given statements. This will be the first pair of congruent sides. Next, for our second statement, since the reason is given, what will be our statement? That's right. The answer is J is the midpoint of line segment SM. Since the reason is given, you are going to write the second given statement, which is J is the midpoint of line segment SM. Next, for number 3, Sj is equal to Mj. What will be the reason for here? The answer is definition of midpoint. The reason will be definition of midpoint since J is the midpoint of line segment SM. By the definition of midpoint, we can say that Sj is equal to Mj. Next, the reason for our statement 4 is the definition of congruent segments. What will be the answer for our statement number 4? The answer here is line segment Sj is congruent to line segment Mj. Based on our fourth statement, by the definition of congruent segments, if we have 2 equal segments, we can say that the 2 segments are congruent. Thus, line segment Sj is congruent to line segment Mj. So this is the second pair of congruent sides. Now, for number 5 or for our fifth statement, angle CJS and angle DJM are vertical angles. What will be the reason for our fifth statement? The answer here is definition of vertical angles. The reason is definition of vertical angles. Using the given figure, we can say that the angle CJS and angle DJM form a pair of vertical angles. Next, for our sixth statement, the reason here is the vertical angle theorem or the VAT. What will be our statement for number 6? The answer here is angle CJS is congruent to angle DJM. By the vertical angle theorem, which states that the vertical angles are congruent, we can say that the angle CJS is congruent to angle DJM. That is a pair of congruent angles. Next, for our seventh statement, triangle CJS is congruent to triangle DJM. What will be the reason here based on our illustration? That's right. The answer here is Sss Congruence Postulate, or the side, angle, and side, which is A is our included angle. As you could see in the figure, angle CJS is the included angle of line segment SJ and line segment CJ, and angle DJM is the included angle of line segment DJ and line segment MJ. Therefore, the reason for the last statement is Sss Congruence Postulate. Next, let's proceed for our example number 3. The given here is line segment OE bisects line or angle HOP, and line segment OE is perpendicular to line segment HP. Let's prove triangle HOE is congruent to triangle POE. Again, for our first statement, always start with one of the given statements, and that is line segment OE bisects angle HOP, and the reason here is given. Next, for number 2, we have angle HOE is congruent to angle POE. And the reason here is the definition of angle bisector. Since line segment OE bisects angle HOP by the definition of angle bisector, we can say that angle HOE is congruent to angle POE, and this is a pair of congruent angles. Next, for our third statement, we have line segment OE is perpendicular to line segment HP, and obviously the reason here is also the given. Next, for our fourth statement is since line segment OE is perpendicular to line segment HP by the definition of perpendicular segments, which states that perpendicular lines form right angles, we can say that angle HEO and angle PEO are right angles. So therefore, our fourth statement is angle HEO and angle PEO are right angles. The reason here is the definition of perpendicular segments. Next, for our fifth statement, we have angle HEO is congruent to angle PEO. The reason here is all right angles are congruent. Since angle HEO and angle PEO are right angles, we can say that they are congruent because all right angles are congruent. And this is another pair of congruent angles. Next, for our sixth statement, we have line segment OE is congruent to line segment OE. And that is the reflexive property of congruency, or the RPC. Because line segment OE is a segment common to triangle HOE and triangle POE. By the reflexive property of congruency, which states that a segment is always congruent to itself, we can say that line segment OE is congruent to line segment OE, and this is a pair of congruent sides or side. Next, for our seventh statement, triangle HOE is congruent to triangle POE. What will be the reason for our last statement? The answer here is by Sss Congruence Postulate. Because since we have two pairs of congruent angles and one pair of congruent included side, and that is line segment OE, triangle HOE is congruent to triangle POE by Sss Congruence Postulate. The included side here is the line segment OE. And while the two angles which is between the included side, which is line segment OE, is angle E and angle O. That is our example number 3. Next, let's proceed for our last example. The given here is line segment AC is perpendicular to line segment CS. Another given, line segment ES is perpendicular to line segment CS. And angle A is congruent to angle E. Let's prove triangle CAS is congruent to triangle SEC. For our first statement, always start with one of the given, and that is line segment AC is perpendicular to line segment CS. And the reason here is given. Next statement, or for our second statement, since line segment AC is perpendicular to line segment CS by the definition of perpendicular segments, we can say that angle ACS is a right angle. So therefore, our second statement is angle ACS is a right angle. And the reason here is by the definition of perpendicular segments. Next, for our third statement, we use the other given about perpendicular segments, and that is line segment ES is perpendicular to line segment CS. The reason here is also given. Next, for our fourth statement, since line segment ES is perpendicular by line segment CS, by the definition of perpendicular segments, we can say that angle ESC is a right angle. So therefore, our fourth statement is angle ESC is a right angle. And the reason is, again, by the definition of perpendicular segments. Next, for our fifth statement, we now have two right angles. Since all right angles are congruent, we can now have angle ACS is congruent to angle ESC, and this is a pair of congruent angles. So therefore, our fifth statement is angle ACS is congruent to angle ESC. And the reason here is all right angles are congruent. Next, for our sixth statement, let's use the last given statement. And that is angle A is congruent to angle E. And that is our second pair of congruent angles. So for our sixth statement, angle A is congruent to angle E. And the reason is also given. Next, second to the last statement, a segment is always congruent to itself. So, by reflexive property of congruency, we can say that line segment CS is congruent to line segment SC, and that is a pair of congruent side. So therefore, our seventh statement is a line segment CS is congruent to line segment SC. And the reason here is by reflexive property of congruency. And now, for our last statement, obviously, let's prove triangle CAS is congruent to triangle SEC. What will be the reason here? The reason here is by what? So let's explain first. Since we have two pairs of congruent angles and one pair of congruent non-included sides, and that is line segment CS, therefore, triangle CAS is congruent to triangle SEC by AAS congruence theorem, or the angle side, and that side is the non-included side congruence theorem. Now, that is our last example. So proving triangle congruence needs a lot of critical thinking skills. You need to have patience in understanding so that you will know what postulate and theorem to be used. It is also helpful to use illustrations for better analysis. Again, this is our lesson for today, which is proving triangle congruence. Thank you for watching.